Hi, hello, this is Yoga Priya, Assistant Professor, Department of Physics. So today we are discuss about potentiometer calibrations of voltmeter. So the first one, precision voltage measurement, calibration voltmeters with the potentiometers. So in this experiment we have to use the potentiometer kit. So the potentiometer calibrations, the given low range voltmeter using potentiometer and draw the calibration curve. Make connections as primary circuit connect positive terminal of accumulator with potentiometer and A connect the negative terminal of accumulator in series with keys and rheostats and potentiometer and B. And these presentations explore the critical role of potentiometer. We focus on their use in calibrating low range voltmeters, and potentiometers offered unparalleled precision for true EMF determinations. And then next, what is potentiometer? So potentiometer, we have to four types. These are separated: precision instruments and null deflections and high accessory and resistance wire. The first one, precision instruments. The instruments we have to use in physics labs measure unknown EMF or potential difference with high accuracy. And the next, null deflections. Null deflections we have to use only galvanometers operate on the balancing principle, ensuring no current draw. And then high accuracy. So high accuracy, the apparatus will be used in high resistance, does not draw current, leading to highly accurate measurements. And then resistance wires we have to use to join the apparatus. It will utilized a long uniform resistance wire, typically 1 to 10 meters. So 1 to 10 meters wires we have to used in jackies. A potentiometer is a key tool in electrical engineering. It provides precise voltage readings. Its unique operations principles ensure minimal interfaces. And the next, principle of operating voltage divisions. So in this second diagram we have to use voltmeter. So voltmeter measured a current. The next, compare voltage. So compare voltage or unknown voltage to a known reference. And then constant current, a stable current flow through a uniform resistance wire. So the wire is uniform resistance and proportional drop. The voltage across any segments is proportional to its length. So we have to use some scale, meter scales, 100 meter scales we have to use the experimental work. And then balanced achieved. Galvanometer shows the null deflections indicate no current flow. So the potentiometer kit, we have to move the jack key. The galvanometer shows the zero deflections. And the core principles reals the finding the balancing point at this point is known as EMF. So the galvanometer shows a null deflections in this point is called as a EMF, equal the voltage drop across a segment of the wire. So used some Daniel cells. So driving cells supply stable current to the potentiometer wire, typically 2-volt lead acid batteries. And the next, galvanometer, a sensitive current detectors used to identify the precise null points. And the next, sliding contact choke. So this called the chakis, moves along the resistance wire to locate the balance point. So we have to use the potentiometer kit. We have to move the galvanometer, show the null deflections. And the next, why use a potentiometer for voltmeter calibrations? There are four. First one, zero current draw, high precisions, independence of internal resistance, and check linearities. The first one, zero current draw. So zero current draw is used as a galvanometer, measure 2 EMF without drawing current, unlike voltmeters. And high precision achieves accuracy up to 0.0001 percentage, supervised to standard voltmeters. And third one, independent of internal resistance, measurements are unaffected by the source as internal resistance once balanced. And then check linearity, enable calibrations at multiple point across the voltmeter scale. And the next, calibration produce for low range voltmeters 0 to 5 volt. We have to use to some batteries. Standardization, setup, measurements, points, balancing, comparisons, and corrections group. So standardizations calibrate the potentiometer using the standard cells. So and then setup, we have to use to low range voltmeters parallel of EMF. And the measurement points is called as the multiple points across the scales. We have the measurement point is a 100-meter scale. So balancing is a potentiometer null deflections, so adjust EMF until voltmeter reads target and find null point on a potentiometer. And then comparisons, calculate the true EMF and determine the error for each reading. And corrections group, plot a curve to identify and corrections and voltmeter derivations. And the finally conclusion, ensuring measurement and integrity. So the potentiometers are indispensable for calibration precision instruments. Their null deflections method ensure highly accurate measurements. Regular calibrations, guidelines, and reliability of scientific data. This precision is fundamental for innovations and quality control across the industries. Thank you so much for watching.